All right, welcome everyone. My name is Casey Wang, and I'm a co-PI on the Fabric project. Thank you all for joining us today for this 13th installment in our Mastering Fabric Tips and Tricks webinar series. Today, it'll be led by Kamal Tareja and Paul Ruth. Next slide, please. Before we begin, I would like to share a few housekeeping items. The webinar will include a live Q&A, question and answer session following the presentation. And please note that the Zoom chat feature has been disabled. So to ask a question, you actually type it into the Q&A box at the bottom of your Zoom screen, and we will be answering it during the Q&A session. Finally, this webinar is being recorded. Later, it will be shared with all the registrants. Next slide, please. Today, we are joined by our presenters, Paul Roof and Kamal Tareja. Paul Roof is an assistant director of the Network Research and Infrastructure Group at the Renaissance Computing Institute, RENC, at the University of North Carolina at Chapel Hill. He is the PI for the Fabric Testbed. His research focuses on programmable research infrastructure, distributed systems, and network experimentation. Kamal Tareja is the senior research software engineer at RENC Fabric, where her work focuses on building programmable cyber infrastructure that enables large-scale reproducible experiment across edge, network, and cloud environments. She leads the development of the core platform capabilities supporting advanced networking services, heterogeneous accelerators, distributed storage, and experiment orchestration. Her research interests include distributed intelligence, decentralized and multi-agent systems, programmable networks, and AI-driven scientific workflows. Prior to her research career, Kamal gained extensive corporate experience architecting and implementing large-scale applications in the communications industry. Her work emphasizes bridging industry-grade system design with experimental research to support disruptive real-world systems experimentation. And now I will pass on to Paul to begin the presentation.
All right. You guys can see my slides all right? Okay. So welcome and thanks for joining. So I'm Paul Ruth, the PI of Fabric, and joined with me is Kamal, who was introduced earlier, and we've been working on this project called LoomAI that we are excited to share to share with you today. So we're introducing LoomAI. It's this new browser-based way to use Fabric that we're now recommending as the primary interface for you to use the testbed. So if you've been using Fabric through FabLib and Jupyter Notebooks and CLI and the portal, this is going to change the way that you do the workflow pretty fundamentally. So I'll let you, I'll get to it and I'll show you all the interesting things. Next slide. Okay. So the core message today is simple. Like LoomAI is the new recommended way to use the Fabric interface, is the new interface for Fabric. This does not mean Fabric is changing underneath. So your accounts and your projects and your allocations and your existing FabLib code and all your Jupyter notebooks and artifacts that you've written, they all work with LoomAI natively and unchanged. So LoomAI just sits on top of the same Fabric APIs. What actually is changing is just the front end. And so instead of starting with a blank notebook and bouncing between the portals and terminals and artifacts, you can just have those all in one place with a whole bunch of extra tools that'll make things useful. The screenshot here is the resource map. I just wanted to highlight it early because LoomAI is not just a pretty topology editor. It'll actually helps you see the testbed you're using, see all the sites and the links and the resources and the states. And it's an interface is in the native browser, and it's very visual. It's AI assisted, which is going to be a big part. You'll see this, that there's a lot of AI tools that are built into it, but it's still fully just Fabric underneath. So by the end of this hour, you should kind of know what LoomAI is and have enough information to get started, and we'll point you towards some installation instructions. So I can start by acknowledging where most of you are coming from. So if you use Fabric today as a user, your workflow probably looks like this. So you open up Jupyter Hub, you spin open a Jupyter notebook, you write 30, 40, 50 lines of FabLib code just to declare the topology. You submit it, you wait for a while, something goes wrong. You have to tab between notebooks and portals and terminals to try to figure out what state things are in. When you finally get in and it's all working, you'll want to publish to the artifact manager. It's always been there, but it's a separate UI, separate workflow. You have to leave your notebook, manually package the files, fill out the metadata, um, and send it into the artifact manager. If you want to get something from the artifact manager, you have to go to a separate place, pull it in, open it up, and figure out how to run it. Um, this is it's nothing wrong. This is not none of this is a flaw in Fabric itself. The testbed works fine, but these are just kind of places in the workflow that we can sort of optimize and make it better for you, easier for you, a better user experience. Um, and this is what LoomAI was built to solve. So this is just a high-level LoomAI workspace. I'll show you the tool in more detail in a minute when I go through a bunch of demonstrations of using it. But you can see a picture. It's a drawing tool, but it's not just a drawing tool. Um, you can see the slice topology. You can have terminals within the same browser window and let you log into the slice. Um, it's kind of the organizing principle here is that the experiment, the tools around it, the artifacts it produced all kind of live together in one space and can be shared and accessed in one space. Um, so it brings together the visual topology editor, an AI assistant, which will be key, terminal windows, files. It has Jupyter, in fact, built into it. So your Jupyter notebooks all work out of the box. There's a viewer for viewing web apps that you might launch inside of Fabric. That's always been a challenge for people to use. You can see all the resources. You can see the marketplace of artifacts. And also interesting is that it runs locally on your laptop in a single Docker container. So it's a Docker container running on your laptop that uses the same Fabric APIs to talk to Fabric and the same APIs that you've always used. Um, It's important shift is that AI or LoomAI shortens the distance between sort of designing and running and observing and sharing your experiment. And in the next few slides, I'll show you a couple different pieces. The manual design of a slice, the AI assisted creation of a slice, ways you can go towards autonomous experimentation where the experiments run to completion on their own, ways to reproduce and share your experiments. And then we'll switch over to a live demo. So first, just the visual design. So the topology editor is kind of the main part of the user experience here. So instead of writing a topology as code, what you can do is drag nodes into the canvas, connect networks, configure the details of it visually. You can set the cores and the RAM and the disk and add any kind of components you want, the GPUs and SmartNICs and FPGAs. All that can be done through the web interface or the GUI interface. Um, uh, in the screenshot, it's a close-up of the design view. You can see in the left panel is where you can kind of choose different components and VMs and networks to add to the canvas. And on the right is the canvas that shows the structure of the slice and a topology design. In the demo in a minute, I'll show you how to build one of these from scratch. But I would add that we hopefully will move on and be able to show you how to build these slices using AI tools, so you don't have to actually build them manually. So the second way to do it, like I mentioned, is to use the AI-assisted experiment creation. So the way this works is that inside of LoomAI there is a somewhat familiar kind of chat interface that you might use. It's connected to LLMs that are hosted on Fabric. So there's self-hosted open weight LLMs running on Fabric. Although you can, if you have your own API tools, connect it to bigger LLMs that are maybe in industrial environments or something else that you have running yourself. So you have a little chat on the side, and you can just talk to it and say, create a slice that has 3 nodes in a ring, install iperf, and prepare the analysis, and it'll try to do it, which is the idea. And then later on, I'll show you how to do this using plain English. But as a separate AI, separate from the AI assisted creation, is the idea of having autonomous experiments. So an autonomous experiment is an experiment that runs all the way through on its own. So it provisions the slice or slices, configures the environment, executes the experiment, collects and logs the measurements, prepares the results, maybe cleans up afterwards. Kind of two types of the 2 ways to think about this. One is you can fully script out your experiment like it's a reproducible artifact that you might publish with a paper and have it run from start to finish. This is great, and you can do this by hand. But you can, from the previous slide, I'd like to point out that you could also have these AI tools help you create these scripts that will run your experiments from start to finish, and that would be an autonomous experiment. But another thing you can do that's even further is you can actually create AI agents inside of LoomAI or inside of your slice that can actually manage the slice for you. So we're hoping people move towards that as they get more familiar with LoomAI. And I'll show you a couple examples of doing things like that. So in this picture, this is actually an experiment that we ran using the AI tools and LoomAI that is trying to tune the host to get the most bandwidth between a pair of Fabric VMs. And one way to do that is to have a script that predefines a parameter sweep over different tuning parameters that you might have for your host, and then just run iperf over and over again as a script. But in this example, what we actually did is we deployed agents using a tool called Pydantic, and inside of that, those agents are actually working together to try to figure out how to best tune the host in order to get the best bandwidth. So we hope people move on to do some of these like AI experimentation as well. And of course, you're going to want to package and share your experiments. So LoomAI does a couple of things. So it introduces this concept of a weave, and a weave is a self-contained runnable experiment. It includes the topology you might run, or maybe multiple topologies you run, scripts, parameters, execution logic, steps for collecting the data, steps for analyzing the data. You should be able to, if you run a weave correctly, if you set it up correctly, you should be able to press run and have the experiment provision itself, execute unattended, collect the outputs, leave behind the results. But underneath, all a weave is a regular Fabric artifact with a hook that knows how to start it. So there's just a script file that's inside the artifact that LoomAI knows about and can be used to kick off the experiment. So if you have a complicated set of scripts that will script your experiment from start to finish, and you put it into the weave in the right place and tell LoomAI about it, your experiment is now an autonomous experiment. And this is what we're introducing the concept of a weave as part of LoomAI. But just know that all it is an artifact, regular artifact, with a script in it that's in the right place that knows how to kick off the experiment. And then also inside of LoomAI, we have the concept of a marketplace or the marketplace. This marketplace is really just the regular old existing artifact manager under the covers. It's the same backend, the same artifacts, but now it's part of this experiment workflow that is really easy to pull the artifacts into LoomAI, create artifacts out of your experiments, publish them, and share them with everyone because it's all part of the same interface. So now you can easily browse, deploy, modify, publish your artifacts and weaves and experiments from one place. And I'll show you how to use this in just a minute. And then it's worth noting that the artifacts that you've already put out in the artifact manager, they all work with LoomAI, and I'll actually show you us using an existing artifact within Loom. So I want to be explicit about this because it's because it matters to people with years of work investing in Fabric. So LoomAI does not replace Fabric. It definitely sits on top of it. Everything you built keeps working. Your same accounts, the same projects, the same allocations, the same APIs, the same CI logins. a full Jupyter environment is inside of Fabric. So all of your existing Fabric notebooks will work inside of LoomAI. So if you have years of notebooks, don't throw any of that away. You just gain a much better workflow around them. The marketplace, which I'll show in the demo, will make it really easy to access your existing artifacts and share them with everyone. We didn't build a new system. We just integrated the existing one into LoomAI and gave it a much better interface. If you've already published artifacts, they're already there, and you can find them in the marketplace today. We're not really asking you to migrate anything. We're just upgrade the front end and use all the interfaces that we have, or the new interfaces that we have. So next, I'm just going to go into a live demo, and I'm going to show you using this. Hopefully, some of these things will take a few minutes to boot or run. If you have questions, I suppose you could ask them in the chat, and we might have some time to answer them in between runs. But mostly what I'm going to do is I'm going to build a slice in the editor and deploy it and show you how to do that. And then I'm going to show you how to share and find and search for different weaves and run them, and then show you how to use some of the embedded AI tools to do some Fabric or some LoomAI things. Okay, so now I have to switch the way I'm sharing. So I need to stop sharing PowerPoint. Come over here. And then share, and I'm going to share my whole desktop and do a demo here. Okay, so now you guys can see my desktop. All I have is a browser here. I will note that LoomAI runs as a Docker container running on your laptop. And all you have to do is follow some instructions that I'll show at the end of the talk, where you can, install the Docker container. And then once it's up, if you just go to, it runs a web server, but the web server is running on your local laptop. So if you go to localhost 3000, this is the shut this down so you can see it. This is the LoomAI running. It's like I said, it's just a web service running inside inside a Docker container on my laptop. I have a couple slices up and running because those are like pre-baked ones. I'm going to show you some results from, but generally you won't see any of your slices here, but you can see them. So if I open these up, you'll see that these are my slices with different VMs in different places and different networks and that kind of thing. But we'll go through a bunch of slices and you'll be able to see more about how this works. Okay, so what we're gonna do, the first thing is I'm just going to show you how to create a brand new slice. So we have over here in this corner, we have the editor panel. And then in the main panel, if I switch to the topology view, this is just a canvas where you can draw a new slice. So you're going to go up here, you're going to hit the new button. It's going to ask you to name your slice. Would be really creative and call it my slice. So I created my slice. Now I have this empty slice in my canvas. And what I need to do now is add some VMs to it or some networks. So if I go over to the slice editor on the side, if you don't see the slice editor, it might be minimized. So you can minimize all of these panels, and you can see this little pencil here. You hit the pencil, it'll open it up. So you can see over here is a bunch of other things that you can open up, and we'll go through those a little bit later. But for starters, we'll start with the editor. So in the editor, you can see you can choose which SSH key you want. I have one installed in here. It's the default one. We'll just use it. If I could hit the slivers button, you can see I have a drop down that has no slivers in it. So what I need to do is add some slivers. So if I hit the plus button, I can add either a VM or either an L2 or an L3 network. For starters, I'm just going to add a virtual machine. You can see when you click to add the virtual machine, it gives you a whole panel where you can configure the virtual machine. The first thing is the name. You can name it whatever you want, or you can just let it be called VM1. You can choose the site that you want it to have it on. So I don't know, we can either have it be automatic, or maybe I can choose one. Let's choose Atlanta for now. If you really want to and you want to get specific, you can choose the host that it's on. I'm just going to go ahead and let it be automatic because I don't care which host it's on. You can change the number of cores or the RAM or the disk that you're requesting. You can choose the image that you want to use. I'll just use the default image. Then you could add components. So you can see a list of all the different components that you're familiar with, the GPUs and ConnectX 6 cards and so forth. I'm just going to add a basic NIC because it's easier to find space for that. So if I go here and I say add, now you can see there's a NIC component called basic NIC. And then if I add the node to the canvas, you'll see that it added my node to the canvas. It has a NIC and it's on the Atlanta site, right? That's kind of a boring slice, so I'm going to go ahead and add another VM. Um, I'm going to just let it be called VM2. Maybe I'll pick a different site. I don't know what site's a good site. Let's pick Washington should work. I think Washington's all right. And we'll also add a component, a basic NIC to this VM and add the node. And now it drew them on top of each other. So now we have these two VMs. In our canvas. One's in Washington and one's in Atlanta, but they're not connected. So if I go up here and add another sliver, and I choose one of the networks, I'll just choose an L2 network. And this, if you're familiar with FabLib, you should kind of the same concepts are present here. So I added a NIC, a layer 2 network. Now I need to name it. You can just let it be called net1 if you like. You need to choose the type. In this case, an L2 bridge doesn't work because an L2 bridge is only in one site. So you have to switch it to something that'll work between Washington and Atlanta. So let's switch it to the site-to-site link. And then you have to choose all the interfaces that you want to be part of this. And so here you just select multiple NICs. Here I selected both of them. You can choose the VLAN. You don't generally choose the VLAN, but you can if you like. Now you can, it's optional to, you can have this be just a pure layer 2 network with no IP addresses, but most of the time you want some IP addresses. So I'm going to say 192.168.42.0/24 here. And this is the subnet. The gateway is optional. And for IP assignment, you have a few choices. You can say none, which means you're going to configure them yourself after it's booted. You can have FabLib do everything, or you can user defined. It'll pop up in a little window, and you'll be able to choose them right here in this GUI. I'm just going to let FabLib assign them for me. And then I click add, and now you see that I have this network that is connecting my two NICs. So this is great. I can kind of move them around and see them. You can see up here, this is my slice is a draft. So it's just a draft slice for now. But if I go and I hit the submit button, it's actually going to submit it. And you see it opens up this log down here in the console that says my slice. Redrew them small, so let's drag them out a little bit. And now you can see the log of what's happening to the slice as it's booting. Also, this will pull just like your Jupyter notebooks do. So you can either hit this slice refresh button, which will refresh it. You can see when I hit refresh, it pulled, and now we can see that these turned orange, which I know means ticketed, and I'll show you in a minute how you know that. But then also next to it, there's this drop down with a timer in it, and it's set for 5 minutes, so it doesn't pull too much. But if you make it like 30 seconds or something, it'll pull every 30 seconds, and you'll get updates faster. So right now we're just waiting for these to come up. I can show you in the other view, the slices view. You can see that my slice is there. You can see that it's of state configuring. And if I hit the little triangle to open it, you can see that I have a VM on Atlanta and Washington. They're both ticketed, and there's a site-to-site link in between them. And if you're familiar with Fabric, you know this takes a couple hundred seconds, and then it should be ready, right? So yeah, so you have these two views, the sort of tabular view, but you also have the topology view where you can see it this way and draw and drag around and things like that. Other things that are interesting here, so there's a map view. So if you go to the map view, you can see all the different sites that Fabric has. You can see also, if I turn off the links for the sites, you can see here's the actual slice that I have created at Atlanta and Washington. And if I click on here, you can see the type it is, and it's ticketed, and it's orange, so it's ticketed. Yeah, so you can just see your slice visually on the map. If you want, you can turn that off too, and turn back on the actual resources that are available. So you can see all the resources on Fabric, and you can see the load on each particular site. If you click on any particular site, like Los Angeles is an interesting one because there's lots of connections. But if I click on it, and then if I open up this little tab with the eye for information, you can see that this is actually showing the Los Angeles site and how many components are available and the different resources that are there. And if I flip over to the metrics tab and I hit refresh here, should show it. Resources, show me the resources.
Paul, try some other site. Los Angeles
So,
site is down.
oh, Los Angeles. Okay,
Yeah,
well, that's not going to
sorry.
work then. Okay,
Yeah.
so if I go to like Salt Lake City, Salt Lake City has the same allocation. If you go to metrics, you should be able to see. There you go. So now you can see the CPU load on every node or host in the site, and then the network traffic and all the links into and out of it. And this is pulling from the infrastructure metrics that we have available on the portal. So from the same place. So these are live metrics of what's happening right now. So you have this map view. You can see all of the resources that you're interested in. You can go over to the resources tab, and this is a similar thing. This is the showing the resources in a tabular format. So I won't do Los Angeles, but maybe I'll do Salt Lake City, and you can see all of the resources that are available, both in the site, but also in any of the particular hosts that you have. And so you can use this to try to find. I don't know what I clicked, so that I'm selecting too many things right now. But there you go. So that's the like a resource tab, so you can kind of see what's available. There's also a calendar here, so you can see um, the resources and their availability into the future to see when you might be able to get some of the scarce resources like GPUs and FPGAs and that kind of thing. Let's go back to our slices view and see. Okay, so my slice is now up, and so you can see that the two nodes are active and the main slice is stable okay. And if I click on the My Slice icon here, it'll take me back to the topology viewer. So now I have my slices up. This is great. But how do I use it? So another thing that we have built into LoomAI is the ability to just SSH to these machines really easy. So if I select this Atlanta node, right click it, whoops, right click the Atlanta node and hit open terminal. You can see that down here in this console view, I get a SSH terminal to that virtual machine. Actually, I'm going to check one thing. Oops. So you can see that, yeah, so the slice built and the build is all complete. So, okay, that's good. We're good. So we should see the IP addresses that are there. So if I go here and I type IP address list, you can see that this actually has 192.168.42.2, which is one of the IP addresses from the subnet that I told it to use. And if I come over here to the Washington side and right click it and open its terminal, I will get another terminal and I can say IP address list, and you can see that this is 192.168.42.1, but maybe I want them in the same place. So if I drag this little tab over here, and I'll have my VM2 over on this tab, and I can select my VM1 tab on this side. Whoops. And now I have them side by side. And if I wanted to do a little experiment, like I could say ping 192.168.42.1. And then you can see that I'm pinging from Washington to Atlanta. Inside terminal is just built into my LoomAI, right? So I did all that. So this is editing the slice with the slice editor. You can see you can just drag things in, specify them, move them around, all that kind of stuff. So now what I want to show you is that we have this other tab up here, which is the artifacts. So I already have a couple artifacts here because I have some stuff running that I'm going to show you in a little bit. But these are where you can have your artifacts that you've downloaded to your Docker container that's running on your laptop, and you can use them. And you can just hit run and stop. I'm not going to do that for these, but I will show you on a couple other ones. So how do I get these artifacts? Well, if I go to this view up here, if I go down to the marketplace view, now you can see that I can maybe shut these terminals down because they're not useful right now. So you can see I have a list here of my artifacts. So these are the artifacts that I've downloaded to this container and can use locally. Published artifacts are the artifacts that I've published, and Fabric Marketplace are the artifacts that anybody has published, or published publicly anyway. So what I can do here is I can see every artifact that anyone's published publicly, and I can just get them. I can sort them by all sorts of things. So I can find another author of a artifact, find all the artifacts they've written. Because we've defined weaves, and because we are going to have more weaves out there, and they're kind of a special type of artifact. It's an artifact that has a hook where you can execute it inside of LoomAI automatically. There's a way to sort by just the weaves. And we have a few of them here, but we're going to add even more in the future. So the way you get these, I'm just going to grab the simple Hello Fabric one. You can just hit get and then say get latest. And then downloaded the Hello Fabric weave to my LoomAI instance that I have here. So now that I have it, I can go back to the main view, and you can see that I have the Hello Fabric weave right there. If I go back over to slices, I can see my list of slices. If I hit run Hello Fabric, it's going to say I'm going to run it. And what name do I want to call it? By default, it gives you the name Hello Fabric, but with a random 4 characters afterwards that you don't have, so you don't reuse the same names if you don't want to. But you can change that to whatever name you like. If I hit run, let me close out this one because I don't need these anymore. But you can see it opened up a tab here, and it's got a log file with that weave running. And in a second here, you'll see that the first thing it's going to do is load up what's in the weave, and then it's going to one of the first things the weave's going to do is submit the slice. So if I then hit refresh, you can see that now there's a slice called Hello Fabric that is also configuring, and that was created by this weave, right? Okay, so these are the weaves. I'll show you what they look like in a bit here, but they're if you remember, all they are is artifacts that have a script that you can then run, and because LoomAI knows how to run it, you can hit this run button and the script will run. And in this case, all Hello Fabric does is starts a VM that if we waited a minute, we would be able to log into it. Okay, so are people asking questions yet or no? No. All right. The next thing I wanted to show you is what I have here is a weave that we are calling the Prometheus Grafana weave. So inside this weave is I've already launched it, so I can't launch it now. But if I go and I select the Prometheus monitor weave, whoops. This is, oh, come on. This is a weave that I started earlier, so I can show you some other cool things that Fabric does. So if you look here, this is a weave that has a monitor VM. Okay, put these all so that they look reasonable. Oops, that one goes over here. Okay, so what this is there's 3 nodes here. This one up here is a monitor. Make it fit, I'll be bigger. It's the monitor, and it happens to be at Washington, and it's on a FabNet v4 network connected to the FabNet v4 internet. And there's 2 nodes, one called Worker 1 and one called Worker 2, and one's at Atlanta and one's at New York. They're both also connected to the FabNet v4 network, and they're running. So the other thing that the Grafana, I'm going to say view log, and we can see the log file from that weave running. And now it's just saying it's healthy. But if we come up to the top, we can see that what it's actually doing is it's configuring node exporter on the 2 workers and the Prometheus and Grafana on the monitor. And that's what it did. So on this monitor, we have Prometheus and Grafana running, and on each of these workers, we have node exporter on them. And those node exporters are sending traffic to to the monitor. So what I'll show you here is that one of the challenges people have when they run things on Fabric, because you know that this is behind a Bastion host and it's difficult to access sometimes. So what we've built into LoomAI is a way to run applications that are running on to connect to web applications that are running on the VMs inside of Fabric. So here we have this applications view, and you can select from this drop down here the slice that you're interested in. I'm going to select the Prometheus one, select the node that you're interested in, the port that you're interested in, and you hit connect. And what this is going to do is it's going to create an SSH tunnel through the Bastion host and all the things that you have a challenge of getting through, and connect to the Grafana instance that is running on that monitor node on the other machine. So now we have this is the Grafana dashboard that's showing the traffic between those two worker nodes. Embedded inside of LoomAI, it's good, but it's also can be even better. You can actually hit this button that says open a new tab, and it'll actually launch that Grafana dashboard in a new tab in your browser. So now you can monitor that other slice. Or you can connect to the web UI of the application running in the slice. And in this case, we're using Grafana, but it could be any web UI that you want. All right. So another thing you can do with this, and I'll show you, is that we have in here, you see there is a Jupyter Lab button here. So this actually opens up a Jupyter Lab that is built in to this LoomAI tool. And this is good. So you can see here, it lands in the folder called My Artifacts, and you can see the artifacts that I have are all sitting right there, right? So inside of here, I could go to like the Prometheus Grafana artifact, and you can see what I have here is a weave.json, which is the file that you need to have to be a weave. And inside this weave.json file, there's a bunch of information, including the name of the script that is the hook to start this Prometheus Grafana experiment. And of course, that's telling you to run this weave.sh script, and this weave.sh script just runs just uses this Prometheus monitor.python file that has, if you open this one up, this is just, if you look carefully, this looks a lot like the code that you would have put inside of your Jupyter notebook. So there's a bunch of things in here, like here you go, add fabnet, add node, new slice, all the things you would normally put in your Jupyter notebook. If you just put them in a Python file and then call them from a script, you have a weave. The other thing to note here, yeah, so that's what that is. The other thing you can do, just like with the applications running on the servers, you can open it up in a new tab. So if you wanted to, you could run Fabric or your LoomAI, and it will look exactly like your Jupyter hub that you've been running inside of Fabric, right? And so if you come in here, I got a lot of stuff happening. So there's a bunch of things, but if you open up My Artifacts is where you want to go. And you can see the 3 artifacts you have, including the Prometheus one and the Hello Fabric and so forth. All right, so I'm going to go back over to my LoomAI tab. Somehow those got disconnected. Okay, so I'm going to close out this Jupyter Lab, go back to Fabric here, and you can see that we have, this is the dashboard, this is the Prometheus. Okay. The other thing I'm going to show you here, just so that you can see this happening, is if you go to the marketplace again, a lot of you, I just want to make sure that everyone understands that you can run existing Fabric artifacts inside of LoomAI natively. And we can go here, if you search for, I'm just going to search for examples because I know that this will just take me to the Jupyter example notebooks that we've had before. So this is just a an existing artifact that we've had that has all the Jupyter example notebooks that you probably learned from when you got started with Fabric. So if I go ahead and just say get, it's getting that notebook artifact. And if I go, so now I have it. It's in my list of artifacts that I've downloaded. You can see it's a notebook rather than a weave. And if I go back over here to the Fabric tab, the view, you can see that I have inside this notebooks, this weaves tab, this artifacts, I have now a list of weaves, but I also have a list of notebooks. So once I have this list of notebooks, you can see that this is the notebook that I downloaded. And if I open up the Jupyter lab for it, let me close some of this stuff because I feel things getting slow. I'm going to close this one too. And then I will open this in a new tab. And then what you can see here is this is basically the start here notebooks that you probably started using Fabric. When you started using Fabric, this is what you were learning from. And if I scroll down and I just pick one, let's pick like this FabNet Layer 3 full auto. That's a pretty small but interesting one. And if you just hit play here, it'll run it. It's the reason this works is because inside of LoomAI, we put that's just a warning that it's not an error, it's just a warning saying there's a deprecated package that Kamal's already fixed, but not in this version. But the keys that are in LoomAI are in exactly the same place as we put them in the Jupyter Hub. So this will work out of the box without any modification. And this will look just like you're used to when you use our Jupyter Hub. And in fact, you can see that this slice was submitted here, and it's ticketed, so it's going to take a couple minutes to come up. But if we go back to the LoomAI board, you can see that if I go to slices and then hit refresh, you can see that my slice with capitals is being deployed, and this is the slice that I just deployed in that Jupyter Hub or that Jupyter lab over there, and you can see it's ticketed and it'll come up when it decides to come up. So yeah, so you can see we have inside of LoomAI, we have a full Jupyter lab that works exactly like the Jupyter Hub that we have provided for you. The one difference, the main difference that everyone's going to like is this is running on your laptop, which means you have your full CPU, you have all the memory that is in your laptop, and you have all the disk that's in your laptop. So if you have lots of data or like really big things, if you run it this way, you will always have enough space for all of your things. Okay, so I'm gonna let that run for a little bit. The next thing I'm gonna show you is if we go back to the Weave tab, we have this Prometheus Grafana notebook or Weave that is running. I showed you it in this tab here so we can see it in a more graphical way. And oops. See it in a more graphical way, which can be nice. You play around with all these things that say fit and redraw. There's a bunch of little tools that'll make it kind of nice. I don't know why that keeps doing that. Come back here. I don't know why it's doing that. I'm going to make it redraw to one of these other predefined ones. Okay, there we go. Now you can kind of see it. I honestly don't know why it's doing that. Something weird is happening with the drawing tool, but I'm just going to let it draw this way and then leave it alone. Okay. Okay, so anyway, this is our slice drawn in there. One thing that okay, good enough for me. One thing that is interesting about this. So if I go, so here's worker one. Let's open up a terminal, worker two. Let me see. Open up a terminal. And then here's the monitor. And I don't want to open up two terminals. I just wanted to open up the one terminal. Make this a little bit wider. And I'll grab my monitor and put it over here. Grab worker one and put it over here. And then do worker two in the middle. Drag these out. Oops. Let's shut this down. I think that the Jupyter in the background is misbehaving. Okay. Okay, so one thing we can notice here, one thing like we'd use as an example a lot of times in Fabric is we run iperf a lot. So right, so if we run here and I can in this terminal I'm gonna type iperf. You can see that iperf is not installed there. iperf is also not installed here. Oops, well that's not spelled right, but it's iperf 3 anyway, and it's definitely not installed. So what we're gonna do here is we're going to use some AI tools to like make this work better or make this work. So I'm going to open up this tool here. And you can see that this is the LoomAI assistant. And if I drag it over here and I get rid of my editor button, and what this LoomAI assistant does, it is actually just like a chatbot that you would use for different AI things. However, it has it knows a lot about Fabric already built into it, and it has a RAG that knows about how Fabric slices and different types. So you can ask it interesting questions, like for example, you can say, "Tell me about my slices," or something like that, and it's going to go off and it's going to make a query to FabLib, and it's going to find all the slices that you have active. Of course, I have quite a few of them here, and it's going to list them all off, and it's going to tell me like some basic things about them. You could also tell it to delete slices or whatever you want. That and we're going to show you some more advanced things in a second here. I'll actually do this, and then I'll show you I'll talk about it a little bit more in a second. I gotta grab from, I have another, yeah. So what I want to do here is I want to, well, I guess I have to just type it. Okay. So one thing you can do, so I have this Prometheus monitor slice up, and you saw that I don't have iperf installed. But what I can type in here is I can type things that will control my slices. It'll create slices, delete slices, or control them. So I'm going to type in here, consider the Prometheus monitor slice get worker one, get the VM. It's called worker one or one and worker two. Install iperf 3 on worker one and worker two. Run a 60-second bandwidth test. iperf 3 bandwidth test between worker one and worker two. Report the results here. So I'm just going to tell the AI assistant to do that, and it's going to go off and start thinking, and it's going to do this for me, which is really cool. So you can see it knows how to call a bunch of tools. So it's actually calling the FabLib get slice to get the Prometheus slice. And then it's going to do an SSH execute that if you're curious, you can look at it and you can see it's trying to find iperf 3. And if it can't find it, it's going to install iperf 3. on the monitor and the worker. And it's just gonna do this. So we're gonna let this chomp away and do that. I don't think I can't open this anymore, can I? And I'll tell you a couple little things about this. So you can see up here that I have in this LoomAI, it says Quinn3 Coder 30B. This is actually an LLM that's running on a Fabric GPU. In fact, it's on an NVIDIA Spark that we have. And this is available to everybody that is a Fabric user. You have to be added to a special project, so we have to enable it for your account. But if you request this access, we will give it to you. It's not. Eventually everyone will have access to it by default, but for now we want to roll it out to people that are interested, and so we can get feedback from you. But I can't drop down this menu. But if you drop down this menu, you see that there's a few other models that you can choose from. There's also these are models that we're hosting on Fabric. NRP also hosts some models that you have available that are available to you. If you have an NRP project and an account that has LLM access to NRP models, you can add them to your LoomAI, so you can use their LLMs. And also, if you have your own API key for any LLM API that you have available to you, whether it's a really expensive one you pay for in like a big commercial provider, all the way down to if you just want to run it on your laptop and you're running LM Studio or Llama or something like that, you can connect it to this, and this tool will use your LLM as a backing for it. Yeah, so we'll let this run for a little bit, and we'll see where it ends up. Are there any questions yet? Yep. Okay, so you can see, oh, it already did it. So you can see if I run down here and I say iPerf 3, it's installed now, right? So you can see that it actually has iPerf 3. And you can see it got like 1 gigabit per second as a result, which isn't very good, but I didn't tune it or do anything. I just said start 2 VMs and go. And if we looked at the Grafana output, we would see 1.2 gigabit happening on the output. Okay, so this was an example of how to take an existing slice and configure it using the AI tools. Something else you can do, as long as I can get this. So this is very new, and we're getting better at. There it goes. Come on. No, you want to. There we go. Okay, so just make this bigger. One of the other things you can do, and I actually have, so I don't have to type the whole thing. I actually pre-typed it over here. You can say things like, you can just create an entire slice with this. So I'm going to go, and I have an entire string. I'm going to copy, I'm going to paste over here. And what this says is I'm asking it to create a slice that includes, I'm going to hit enter so it'll go, create a slice that includes 3 nodes on 3 different sites, all connected to Fabnet v4 with IP addresses automatically configured. The VMs should use Ubuntu 24. So I just told it to create a slice. So the first example, I told it to configure some things on an existing slice. This time I'm telling it to actually create the slice. So you can see it actually knows how to use, it's going through and doing things that look a lot like creating FabLib tools or using FabLib tools. And that's what it's doing. In fact, it's creating a slice request, and you can see now it's in the process of submitting the slice. And if I hit refresh, we might see it. Yeah, so now we can see, we can see that there's a draft of the Fabnet 3-node slice. So it hasn't submitted it yet, but it's now submitted, I'm pretty sure. So if I hit refresh, it should say, oh yeah, I forgot that's actually part of the step. So like in this case, it actually created the slice. It created the slice request as a draft, but it has not submitted it. But if I wanted to, I could say submit the slice, right? And in fact, in the first request, if I said submit the slice after you create it, it would have done that. So now it's going to submit the slice. And we should see in a second that this draft slice will go from draft to I hit refresh. And now you can see that it's configuring. And a second, as soon as it goes, as soon as it gets further along the process, we'll see more information. So in this particular case, this is me actually using the AI assistant to create slices on Fabric. Yeah, okay. All right, and the last thing, so now this is ticketed, and of course when this comes up, we'll be able to like install iPerf on it and run it or whatever you want to do. So one of the last examples that I wanted to show you here was this weave that I have here that's called Network Agentic Tune. So one interesting thing, so this is actually a weave that I created, or actually I didn't create it, AI tools created it for me. And what it does is it's going to use an API key that I have. It could use the API key that you can get to use the Fabric LLMs. And it's going to deploy a slice. Actually, I can open it and we can see what it looks like. Here's the agentic tune slice. So this is it has two nodes. One's at Salt Lake City and one's at Starlight in Chicago, and it's connected with an L2 link, right? But inside those two nodes, I had it deploy a tool called Pydantic, and Pydantic was instructed to use the Fabric LLM service in order to have the Pydantic agents be able to reason using the LLM. And then I instructed the network agentic tune weave to tell the two agents to work together to try to tune the node, the hosts, in order to find the most bandwidth with iPerf 3. So the difference here is that instead of just running iPerf 3, this is actually deploying agents into the slice who now can tune the two hosts. And then those agents are going to work together to actually tune the host and then try to get the best bandwidth. And just to be clear, when I created that is actually a very complicated weave request. So I didn't actually use the LoomAI tool to do that. And I will show you just in case you were wondering how to do it. I have another thing. This is just a console. And what you can do is down here, let me close some of these so I have more space. What you can do here is open up another terminal here. This is a local terminal. So this is a shell that is on the Docker container that we're running. And if I wanted to, I can just say work. You can see it's work. It has a directory called work. This looks just like the Docker hub or the Jupyter hub that you tend to use. And if I go into work and then I go into my artifacts, you can see all my artifacts there and things like that. So this is just the file system of the container that all of the stuff is running in on your laptop. So if I go back to the home directory, now what I can do, this is how I like to do it anyway. I take my little tab here and I drag it up to this other console on the side. And then maybe I make this narrower so that I can have more space over here. And then instead of running the LoomAI assistant, which uses the self-hosted open weight models, I can actually run other types of commercial LLMs. So here I'm running actual Claude code, and Claude code is actually quite a bit more powerful than is one of the more powerful ones out there. And now what you can do is all of the things that I was doing with LoomAI, I can do with Claude code, but it's just a more powerful coding agent that can do more things. And with that, I was actually able to create this network agentic tune that in fact is deploying agents on the machines that are cooperating to like do the task they're trying to do, as opposed to me creating just a script that does it. And then the other thing I had it do was for this particular network agentic tune, if you open up the Jupyter lab for it, it does everything end to end. So if I look inside here, it has the weave.json file, it has a log file, it has the script that runs it, it has the agent, the network tune and the tune agent. And these are all of the things that are launching the slice and launching the agents and all of these things. And if I open up the Jupyter notebook that's in here, this actually is a, 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 a Jupyter notebook that was automatically creating by the agents that actually processes and analyzes the results of the run that it made. So let me make this smaller so that we have more room to see. But I ran it previously, so you can see that it loaded the results that are stored in this results folder. And then it pulls the results. It does a little bit of analysis of the results, and it found what round was best as it was trying to tune the machines. It made these graphs that showed the best bandwidth that it was able to find. So like how the retransmits were happening at different times. So, and a bunch of other just statistics about, or just analysis of the data that came back from it trying to tune these hosts to get the best bandwidth. So the key thing to note here is that using the Claude Code tool inside of LoomAI, I created a weave, which is an artifact that's just a package of all the code. And inside that artifact, it has a script that will run the entire experiment end to end. But inside that experiment was two agents that were then working agentically to try to tune the machines. And then once they were done, all the data was pulled back into LoomAI, dropped in this results folder, and then the Jupyter notebook that was automatically created did the analysis of it. And I wrote no lines of code for this. And I think that that's the really cool thing is I didn't write any lines of code and all of this happened. And if I wanted to, I could go back and tweak the code to make it do something hand built, but you really don't need to. You can ask Claude to do that. And that is the examples that I have for you. There's quite a bit there. I know this is probably a lot. Let me switch back to some slides so I can show you a couple last minute things. So I want to do this interview, and I'm pretty much right on time, I think. So here, share. Now you guys see my slides again, I assume. So this is the wrong ones. Let me grab this one. This is the slideshow, presenter view, and then share. And now we're back to where we were. Yeah, so now we're back to the live demo, and we finished the live demo. So then the next slide here is just to say, before we wrap up, I just wanted to make sure that I really emphasize that we have LLM services deployed on Fabric, and it's kind of separate from the agent story. So Fabric is hosting open weight LLMs that all of you can use with your API keys. LoomAI uses them by default. So if you want to use LoomAI with our open weight LLMs, you can, but it's not the only way to use it. You can use your commercial subscriptions, or you can use, if you have API keys to any other LLMs that you have access to, you can use those. And you can use our self-hosted LLMs in agents that you're running inside of your experiments if you want to. So you can use those agents to summarize your logs or interpret the results or whatever you're trying to do. So basically the message here is we have this self-hosted LLMs. Use them for your experiments that you're running on Fabric, both inside of as the back end for LoomAI, but also within your experiments. And what we're really kind of pushing towards is having something we want to call the agentic sandbox for research. So this is a place where you can use any sorts of LLM or agentic tools to both create, manage, and run autonomous experiments or deploy the experiments throughout the infrastructure to do your AI research in the future. Yeah. What's next? We do have cross testbed experiments that we're working on. If you look inside the LoomAI, you'll see that we have some tools to start using Chameleon. They're not really ready for regular users to use. They're a little buggy still, but soon we'll have the ability to add Chameleon um, uh, servers to your LoomAI experiments. We want to enable these AI managed campaigns so that they can orchestrate lots of experiments over time and collect all the data for you. We're going to have more polished results in notebooks and things that you can run inside of Fabric. And then we also just want to have like a growing marketplace of all of your artifacts and weaves that you're sharing with each other. So help us grow that marketplace. We're going to add a bunch ourselves, but we're very much excited to have you contribute your own. Getting started today, this is where you might get started. So if you go to the GitHub repo, the Fabric Testbed GitHub repo, there's a project called LoomAI. That's where you can get, there's instructions on how to install LoomAI on your desktop or your laptop. All you have to do is run a Docker Compose file, and it starts a Docker container. But we also have on YouTube, we have YouTube videos. I don't know if you've seen them before, but the webinars are on YouTube, and they're in this particular YouTube channel. But we've created a LoomAI playlist. Right now it's pretty skimpy. It has 3 videos on one, how to install LoomAI, one, how to get your tokens working with it. And the last one shows you how to just create your initial slice. But I've showed you a whole bunch more than what's in those videos, and hopefully that'll get you started. Thank you. And I guess Kamal and I will gladly ask or answer any questions that you have.
All right. Well, thank you, Paul. Now we will get right into the Q&A session. So we'll begin with some questions submitted during this presentation. And the first question,
Yeah.
how can we get a test account?
If you have a Fabric testbed, or if you already have an account on Fabric, then you have an account on this. You just have to download the tool. But if you don't have a Fabric account, all you do is you go to portal fabric-testbed.net. And I'm not logged in, luckily. So if you go to this and you hit the sign up button, if you're from a academic institution or some other institutions that are in common, you can create an account. You will, to get access to all of the resources, you will need to have a project, and that requires having some responsible person apply for a project and then add you to the project. It might be you yourself might be the responsible person. Responsible people include, professors, senior research scientists of types like that. But they do not include students. So if you're a student, you have to get one of your professors to lead the project and be the responsible person. But yeah, so if you just go to the Fabric portal, hit sign up, you'll have an account. Then you'll have to get into a project.
All right. Next question. Can we update the slice configurations without deleting it with LoomAI?
Yep, you sure can. Yeah, it's just like the modify slice that works in in
In Jupyter.
in Jupyter Hub and other places. Yeah, it works the same. So keep in mind that underneath the covers, LumaAI is just using the regular fablib calls. Like there's nothing special about it. It's just calling fablib. So anything fablib can do, LumaAI can do. And if there's something that it can't do that fablib can do, then tell us about it, because it should be able to.
Right. Next question. What is the reason to choose a local Docker container instead of a hosted service?
Primarily because that a lot of people on the hosted service, they run out, like we have to pay, back up a little bit. our Jupyter Hub that we have now, we pay for it using cloud credits, so it's in Google Cloud, and because of that, we keep the space that you have pretty limited, and a lot of people want more space. If you do this locally, you can have as much space as you want. You can have it access anything that your laptop has access to. I will say that we do have a version of LoomAI that runs in our Google Cloud, just like the Jupyter Hub does, and we're working towards rolling that out. We have to be a little careful because I suspect LoomAI is going to chew a lot more of our cloud credits than Jupyter Hub. So we're kind of just being a little, before we release it to everybody, we want to make sure we can afford it. So,
That's great.
but yeah, so hold on, it'll be there probably.
All right, next question. I found this new version quite user-friendly. One thing I liked in the previous version was that we could see the code along with all the explanation in the Jupyter tutorial. Is there any way to see the explanations in this format as well?
Yeah. I mean, so every one of these weaves, it is in fact, hit reload because that'll actually do it better. Every one of these weaves, in fact, is my laptop is being overwhelmed right now, but okay. It's not even the Loom AI, it's like my browser has gone crazy. I'm running too many things at once, I think. But if you just go to localhost 3000, and if I can grab this and make it go over here, maybe I just make it go away. Where's the button to make it go away? Go away. Let me see. So I don't know why.
Maybe we can go to the Jupyter Lab view, Paul. And
Oh yeah, that should work too. I was gonna show that the Jupyter Lab view will make it better. Actually, it won't because it's
So you probably need to stop, share, and do it again.
yeah. I think I just have too much stuff running right now. Underneath,
I can share
yeah,
if you want, Paul.
bet if I
Yeah.
just restart this, it should work. Okay, there. Now it's gone. Basically, my browser is not even reacting correctly. Hey, if you want to share, come on, you can go for it. Yeah, yeah. So the key is that like it's all just a file system. So I mean, there's multiple ways. You can actually just open up the Jupyter Hub, the Jupyter Lab that's in there. You can open up that in any folder you want and just behave. It's just exactly like Jupyter Hub. Also, you can open up those terminal windows, and you can
Sorry, I didn't have, yeah.
yeah, you can open up a terminal window at the bottom, and you have a file browser, or yeah, you have a terminal that is anywhere you want it to be.
Yeah, so in this case, like for example, I downloaded this existing artifact and I opened up in the Jupyter Lab. So you have all your notebooks and you can still see the explanation if you'd like that way. And this also works for the weaves too. Like for example, like if I download a weave. Everything you download shows up in this my artifacts directory, and then this is the weave I downloaded. So as you can see, it has weave.json and weave.shell script like Paul talked about. So you have all the code in here. You can see and edit if you want to change anything. That we also have a markdown here if you want to read through what it does. And in this case, there is a notebook as well because this is the notebook which does the analysis bit. So if you wanted to see the explanation of the code, it works like the way it was before.
And if you wanted to do it exactly like you did before, where the code for running the experiment is in the Jupyter notebook, that is, you could totally do that too.
Yeah,
If you
like
prefer
this is,
that way, it's already there.
yep.
Yeah.
All right. So the next question, is there an AI component to this where you can query what you might need for a certain experiment and suggestions for specifications?
I think the answer is yes, but I don't 100% understand the question, but I'll answer it a couple different ways maybe. So one of the things that can be frustrating about Fabric is that you submit a slice and there's not enough resources, and it's hard to know that before you submit it. So in fact, those weaves I created, one of the things I told it to do before, like the Python code that is actually going to make the submission of the slice request, for the ones that I really want to work well, I always tell them before you submit the slice, query it and query the available resources and make sure it'll work. And if not, then you can choose a different site if that's okay. So you can actually have the weave know to first look for sites that have available resources and then only use those. So that's one thing. What was the rest of the question? There was like a couple different ways they asked it.
Yeah, just to say that whether there is an AI that you can query to find out what you might need for a certain experiment.
Yeah, I think that's a pretty open question, but yeah, like like any kind of AI tool that you might use, you can have it query like the internet and find whatever it needs. Like those iPerf examples, for example, those agents that run and try to tune for iPerf bandwidth. I always pointed to a website called fasterdata.es.net. So I just told the agents like, you need to tune this to make it as fast as possible. Here's a website that's got a bunch of information for you. Go read that, and they do.
Okay. All right.
Yes, sorry.
Mhm.
I
Go
just
ahead.
wanted to add to what Paul said that, like, for example, if you were looking for specific resources, that is also possible. Like, you can just ask the Loom AI assistant that find me a site where a GPU and a ConnectX 5 is available, and it'll reply back to you.
Yeah, that's helpful. Okay, next question. I'm trying to create a slice and there aren't enough resources. How can I use Loom AI to find a solution? And I think you just answered that.
Yeah.
Yeah.
Yeah,
So
I
if there are enough resources somewhere, you can ask the AI tools to find that place, right?
right.
Yeah, and there, we also have this view called calendar, for example. Sometimes, like if you look for resources, they may not be available now, and LoomAI will come back and tell you that it's not available. But you can now see this calendar view, and it can show you information about up to 30 days, and you can filter on, for example, if you're looking for a ConnectX 7. I'm sure there won't be any, but if you were filtering for specific kind of components, you can look for that and then figure out when would one be available on which host or which site would that be.
Right. So that actually is the next question. How do I use the calendar, the resource calendar to plan and schedule my experiments? And yep. One more question. What are other ways Fabric LLMs can be used? For example, in the Pydantic example you mentioned.
Oh, okay. One way Paul already showed, we could use them for as bidentic agents in the experiments. But if you're trying to use them outside for any other experiments with outside Fabric too, you can use those keys just like you would use for any LLMs you have. Uh, you just need to request the LLM key. Reach out to us either on the forum or on the portal through the portal, and we can enable that for you.
All right. Next question. Can the AI companion help me debug a boot configuration script that is failing on a specific node?
It definitely can.
Absolutely. It's
Okay.
it's so good at that. That's like one of the best things about it is you can like what I tend to do is you write the weave and then you run Claude or something like in the on the other side, and then you can say, tell Claude, run this weave, and if it fails, figure out why, fix it and retry and continue until it's fixed. And it'll just go off and do that. And anyway, Kamal maybe had some other experiences.
No, that's how I have been using.
Yeah.
We just want to point out that like Claude is more powerful than the open weight LLMs we are hosting, so they may be a little bit slow, but they also do a similar kind of job.
Yeah.
That's
And
great.
we'll get better at hosting them and things like that.
Yeah.
But yeah.
So,
Also you can use Codex in it. I've used that in Codex in there as well. So if that's your favorite, it also works. So,
next question. I have files on my local machine that I need on a VM
oh,
during experiment. How does the file manager handle that?
That is
you can,
one,
do you
sorry.
want to show that? Show it,
Yeah.
Kamal. I
I think
didn't.
that is the most cool thing about it. For example, if you have, uh, I do have slices, and
Yeah.
I think I need to select a slice. Um, this is
Yeah. Kamal always has
So
lots of
yeah, you
slices.
just please don't be like I have too many slices. So if you go to the storage tab and you choose a slice, it lets you choose specific nodes. For example, in this case, I just have single node, and you can these are all the files in my container. You can drag drop them, and not only from you can drag drop the files from your container. If you have something in your on your desktop, you just have to drag and drop and
Yeah.
the file would be uploaded. You don't have to worry about finding out the SCP command and any of that.
Yeah. I was
Hmm.
supposed to show that, but I don't know, it slipped from my mind. But yeah, you can just drag stuff from your desktop into these windows and it'll do it. Kamal, also like on the Tokyo side, like double click like one of those like bash RC files or something. So you can also edit files. Yeah,
Uh,
just like bash RC, just click it and then say open. You can actually edit text files in place, even though this one's in Tokyo on a VM. And you can just edit and then hit save if you
yeah.
like. That's
I
built
mean, I'm
into
not,
the tool as well.
yeah.
Yeah. And you can drag files, you can drag folders, whatever. It does like the way it works is that it's creating an SSH tunnel in the background between the container on your laptop and the VM, and it's also the way it creates an SSH tunnel in the same way it always does. It goes through the Bastion host, so you're gonna get performance that is equivalent to going through the Bastion host, but it does make it really easy to do it.
All right.
Yeah.
Next question. How can someone convert their existing artifacts into weaves?
Uh, if your artifact, so the the only thing you need to do is put in the main folder is the .json file that has a bunch of information that can describe like the description of it and all these things. But all it really needs is a JSON file needs a attribute that is like the name of the script that needs to run, and that script has to exist. And then that script will run whatever you want. If you're so not all artifacts, existing artifacts are like they're not even intended to be a one-off running thing. So like we can't really just say that everything has to be a weave because that doesn't even make sense. But if your existing artifact is like a slice that you're running to collect some batch of data, if you put in that file, a weave.json file in a script, it would call it and it would do whatever. Um, because you spent a bunch of time probably putting all of the Python code in the Jupyter notebook, the best way probably would be to ask one of these AI tools to like pull all that code out and like organize it in just regular Python files. But also I know that there have been even before AI tools were popular, tools that will do that to Jupyter notebooks, and you can just go look those up. I think if you've installed Jupyter before, those tools often just come with the Jupyter install. So they might also already be installed on even our Jupyter lab. I'm not sure if that's true or not though.
Yeah,
But
so I think that leads to the next question. What makes a good weave? Are there guidelines for what should and shouldn't be packaged as a weave?
I I don't know. I think that the idea in my mind, I wanted to keep it as simple as possible so that you can be as creative as possible. I didn't want to have too many restrictions. So that's why it's designed to be literally a artifact that has a script that kicks it off, right? So you can do whatever you want. Um, I will say that some things that we've tried to do, which are interesting, like just to, you know, a couple different levels. Like one, if you look at like the Hello Fabric weave, it starts a single node, and then when you hit the stop button, it deletes it. But while it's running, it exists, right? But you don't have to do it that way. Like you can make it so that the weave, like when you hit stop, it doesn't delete the slice. So you can use the weave as just a way to create a slice that you're now going to interact with manually. That's totally fine. You can also have it create a slice that it runs like one big experiment on. Or we've done ones where we want to actually try to find the bandwidth that you can get between any pair of sites on Fabric. So we had a weave that like iterates over time and creates a whole lot, like a whole bunch of slices in order, like a pair, and then it figures out the best tuning for every pair. So you don't have to think of it as being a slice. It can be like a series of slices.
Okay.
And so there's that. That's some examples. But also, I want everyone to be very creative because like I don't want to limit the ideas.
Sure. Um, so next question about the Weave. How does sharing to the artifact marketplace work? Is it public by default, or can they
Uh,
be scoped to a project?
they're definitely scope to the project. Do you want to share, Kamal? Since you're like
Yeah.
half there. Yeah. It's exactly like the artifact manager is today. There's just like a slicker web interface to it. Um, so probably at
Yeah,
a
like you have this these are the artifacts I downloaded, but if you, for example, if you made changes or if you created your new weave or an artifact on LoomAI, by default it'll show up under your My Artifacts, and you if you hit publish, it will be pushed out.
it, you'll click it. Yeah. Well, yeah. So that artifact is probably written by somebody else, or maybe
Yeah,
one of
that's
your other accounts. So if you hit that one, no, it's actually pretty cool. Hit it, and then I don't know if it will do it or not. But you can see it says it'll be a fork because this is somebody else's artifact.
yeah.
So if you hit continue, and then you can fill that out, and then you get the
And
choice in the middle. Yeah,
yeah.
public or project or you only, and then you hit submit or publish
Publish.
fork, and then it does it. Yeah.
Okay, that's great. So next question, I have years of FabLib Jupyter notebooks. What's the migration path into Loom AI?
If you just want to use them the way they are, just copy them in there. But you could also if you probably, if you really want to, you should publish them. And you can make them publish them so that only you are able to see them. And then inside of LumaAI, you basically have your own repository of artifacts that if you make them only available to you, then they're just yours, right? That's probably the way to do it. But if you had them in a big tarball or something, and you just opened up LumaAI and you just drug that tarball over there and untar them, then they're all there.
All right. So final question, can Loom AI create a weave based on the Jupyter Notebook test, or we have to do it using LLM?
Oh no, you can manually write it if you want. I don't think I'll ever do that again, but 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 you can definitely hand write them. I mean, the first couple we were doing,
All
yeah, you
right.
can. I don't know, Kamal, if you want to open up a one of those JSON files and just show what it
Oh,
is.
okay.
I don't know. It's human readable, really, and yeah, I don't know. You might have to.
Um, Let me go to. I have them here. Oh, okay. Since I downloaded them, this Prometheus Grafana monitor is the Weave which Paul ran during
Yeah,
the live demo. So if you see here, there is a weave.json which has the information about the weave. This is the description that goes in the artifact manager and the script which you run.
Right.
And then this is the shell script which triggers your experiment.
yeah, yeah.
All
So
right.
it's just a JSON file, and I think like by definition, if the only thing that's in that JSON file is the script to run, it'll work. But all the rest of the stuff is just kind of candy to make things easier.
All right. Well, thank you. Thank you again to our presenters, Paul and Kamal. In addition to our presenters, we would like to acknowledge that there's a behind the scenes team who have worked together to bring the webinar to production. And that's, as you see, myself and Chelsea Davis, who is our project manager, really worked hard on this. Next slide. Thank to the audience for your participation in the webinar today. In addition to the recording of the webinar, we will also email everyone who has registered with a list of resources. This slide deck will also be shared. There you will find a Connect with Us form. We hope you will reach out to the Fabric team if you have any questions or looking for support. Next slide. Our next webinar will be on June 16 at 3 p.m. Eastern Time. It will be the Stitching Together Innovation with Fabric Users series. This webinar will be focused on new users. We would appreciate it if you know any new users and forward it to them. As a final reminder, if you are already a Fabric user, please submit your Fabric matrix and make sure your project description in the portal is up to date. We do use that information for outreach and we do promote it on our website. So thank you again and have a wonderful day.